Hi everyone. In this lecture, we'll continue studying diffusion course by Hugging Face. We will learn how to guide the image generation into a specific direction we want. So when we train a diffusion model, it it learns to generate the images we want from the data we have given. Now, if we do have no control over what kind of image comes out, because it's a very weird way of the way images are generated. We From noise, we keep removing the noise so that we arrive at a final image. So you could start with the same noise, and each time there might come a different prediction based on whatever is the given image, and we will arrive at the different answer. So there is no control over the kind of output which will come. We have no control over that. We know that it will be based on the data we gave. That's all we know. So we fine tune it on the data we want. Though you can check those details in previous lecture. And if you want to build even further than that, rest of the methods are there. So if you check Stable Diffusion or Midjourney, all of these big text to image generators, they have built in the same way. We start with a diffusion model, we fine tune it, then we optimize it, and all of this incrementally happens. So if you check on the left hand side, fine tuning, guidance, conditioning, then we have Stable Diffusion, and then we have further improvements to this. So with all this, all the diffusion image generation is done. So going for the guidance part, you will find the code for it in my GitHub repository. It is, as always, if you go to GitHub, and I have highlighted this into my pin repository, or you could go into repositories and search for this. So Hugging Face image generation course 3, simple guidance and clip guidance. Okay. So what is guidance? Guidance, if you think of it like as a student teacher situation, teacher is guiding a student, so teacher knows more than student. That's what we generally think as guidance. And conditioning, if we check in this fine tuning, conditioning is goes even more than guidance. Conditioning is, I would say, a more toxic interpretation we could do. It's conditioned just to do what it was trained to do. Guidance is a suggestion, conditioning is a enforcement. So building on top of fine tuning, these are the subtle variations. And if you learn what do they mean from English perspective, you will definitely understand the concept better in the code. Okay. So let's go into the code. Code is always the same. We have these libraries, we import the libraries. Hugging Face has this diffusers library in which everything we need is there. So we master these. If I want to change the code inside these things, I will have to check and the source code of the model. So I execute this, and then this is the existing diffusion based pipeline. So we always in all of the deep learning, we always build on existing knowledge, because fine tuning takes a lot less efforts and compute cost than training from scratch. So if we are to train a student or let's say professional from scratch, it is a lot easier to train someone who has a prerequisites or some related knowledge to what we need to train, rather than teaching a baby from scratch and waiting for baby to grow up to learn whatever we are trying to teach it. So that's why we do fine tuning. So get the pipeline, get the scheduler, and we are good to go. We can start understanding what is guidance. Okay. So check this code, and it is a very interesting code. So what it is doing is we specify a color in which this we want the output of a diffusion model to be close to the color we specify here. So this is the target color. So our guidance is turning, steering the generation in a direction where we want. That's the guidance. So here I have given 0.5, 0.50. The color values are RGB, and the values are between 0 to 1. So, half thing is in red, half is in green. So this is the combination of this here. If I just say this to be 0 and, make this to be 1, I know this is 1 completely for red. So then this is the target. We just change it in the format we want. Don't worry if you don't remember this code. Learn to use the existing code, because I even still now I struggle with these codes. This is just written in such a messy way. So let's not get caught into this. We know that we take the color, we compare this with the image we have, and however far it is from the color we want, that is the error function. And if you know, in deep learning, what do we do? Error function is what tells us how wrong we are. What is deep learning? We become less wrong. That's all we do. Over time, we become less wrong, and that wrongness is given by the error function. So our error function is quite standard. So what we do here is, this is a new error function we have created. And going to the code, this code you will find is a standard code until now. So over time you should be able to understand this thoroughly, and all of these things are constantly repeated. So we get the model input, we predict the noise, then we remove the noise from this thing, then we go through the scheduler and step, and next adjusting what is the next image generation, because we do it in step by step. The loss here is where the interesting thing starts. The only change here is we have the loss we want is built on top of the old one. So it's like this is a train model, and on this we have this color loss being put. So when we do gradient step, it goes and learns into the direction of whatever guidance we have provided. So if you scroll down, so this will only now learn in the direction of what we want. So if I check and execute this, I have given the zero point 0.5 for red, zero point 0.5 for green. Its output it gives in a combination of red plus green, hopefully. The accuracy of the output is not very high. So as you might see, this guidance is based on doing this tiny loss correction for in such a way that this is not really that accurate at helping us improve. So the guidance, it helps us dynamically steer the image where we want, in a direction we want. But as you can see, it doesn't give us any control. All the code is same, just this tiny bit hacks of to include this extra loss function, but everything else is same. So what if we want a better control? Think, what could we do? So that's the next thing. So we want we want to go beyond plain guidance, where we are simply doing something on a color thing. We want a bit more. So another thing we could do is, instead of giving just RGB color for guidance, maybe we could give, I want images similar to this image. So we could fine tune a model for image similarities. So, whatever we can think, we can do it here. Just, we should be able to write that code. So, going beyond the simple guidance, let's go for advanced guidance. And you will find that if you are using image to guide a model, you don't have very control over it. But language, words, you can tell, okay, you know what? I want a dog running on a car who is jumping on a truck, something like that, weird things we could say. And if we can influence where the image is being generated from text, we have a lot more control. It is a lot more useful product. So that is why we have this advanced guidance. And this has something called as clip. Don't worry about this word. Simply know that, we fine tuned the model. We want to improve on top of fine tuning. So we used a simple guidance. Then that is what is too simple. So I want to improve that guidance. So I could just guide on image, or I could include, text understanding also, because LLMs are also fine tuned. It's a all logical leap from where we started a simple diffusion model. So what clip model is it is a existing neural network fine tuned by OpenAI company, and it has been fine tuned to do two things. It takes in a text description, and it also takes in an image, and then it learns how similar the text description is to the image. So it has that knowledge with it. So if you go into this course, you will find that Uh, OpenAI has released some blogs on it, and these blogs you might find it interesting. But the simple word summary is, it's a model OpenAI has done, which understand not just single image, but text and image together. And because images take a lot more size, and training time of images is very large, right? So by being able to tune the images with a very low memory, text is so small, a few words it will take just a bytes, and the image which is generated from it can take megabytes. So that's why this was done. So it internally consists of two models. So if you check internally, it has the complete model has two parts. It takes in a single image, and another part takes in the text thing, and then it learns the similarities between it. So if we check here in the code, everything else remains exactly the same. So if you check this code, going through the timestamp, getting the model input, predicting the noise, going through unit, predicting the noise, and doing the scheduling. So all these things are actually same. Okay. The difference starts from here. Difference is this part, just this. Everything else is same. What it does is, if the internal stage where the image is created, okay, by our diffusion model, we pass that image to the model as image, and with it we give the prompt. So here, built on top of the existing diffusion model, there is another layer which uses another model to kind of like tune the output using text as a guidance. So that's why this is I renamed in a capital called as guidance prompt. So internal output is, checked with the similarities of what the text expects in the prompt. So if I check the prompt, red roses on a green forest background. So it is very similar to what I did here, which is RGB 0.5, 0.50. So I want zero value of blue, and 50% I want green, 50% I want red. So that's how I've written the prompt. So each intermediate step of diffusion generation, it compares the image generated with the text using clip model. And all the models, all the internal images which are closer to this, we tune in that direction. So over time, we get an image in the format we want. So you see, this is also dynamic. A model has been trained already. And on top of that, only while using the model, we are tweaking it. This knowledge of using text is not part of the model itself. No, this is just a simple diffusion model which is being steered in the direction we want with an external model. So this is where guidance falls short, because it is, doing just dynamic time steering towards its goal. If we condition it, so if we condition it towards something, what it is, the knowledge of what we want is built into the model now. So it is further on top of the fine tuning. We, condition it for specific conditions we have provided, and those become part of the model itself. So as you can see, it's all incremental, and each and every step is important for us to understand this whole ecosystem of diffusion models. So this kind of finishes our fine tuning and guidance. And next lecture we'll see conditioning even further, which is very much like this. Code wise, you will find it's very much same as this, just the location changes, tiny bit changes. So that's why we need understanding more. So after this, you can directly jump to stable diffusion or mid-journey, the peak of image generation right now. So you get to the cutting edge very quickly, and then you have to spend time understanding research and doing coding and hacking more so that you can build a better product. So let's learn rest of the things in subsequent lectures.